Okay, Algebra 2, we're down to our last week, 3 more lessons. This section is going to be on geometric, sequences, and series. We talked about arithmetic, and remember, to get the next term of an arithmetic sequence, you add or subtract something, and we called that the common difference, and we called that D. In geometric, it's a sequence in which the ratio between any two terms, consecutive terms, is constant. So now we're going to multiply or divide by something to get the next term. And instead of a common difference, we have a common ratio, and that's the numerical ratio between two consecutive terms. So let's look at these examples. It says, determine whether the sequence is geometric. If yes, then find the common ratio and give the next 3 terms. So you take the second term divided by the first term. So for number 1, 12 divided by 6 equals 2. Then 24 divided by 12 equals 2. 48 divided by 24 equals 2. So yes, it is geometric, and R equals 2. And to find the next terms, you just multiply by 2. 48 times 2 is 96, and then times 2 is 192, and then times 2, so on. Okay, number 2, we're going to take 270 divided by 810. That gives us a third. 90 divided by 270, a third. 30 divided by 90, a third. So yes, it is geometric, and our R is a third. So now we're going to multiply each term by a third to get the next term. So we're at 30. If we multiply by a third, we get 10, then 10 thirds, and 10 ninths for the next 3 terms. Now look at number 3. This one is interesting because it goes back and forth between positive and negative. Okay, arithmetic cannot go back and forth like that. When you're adding and subtracting, it can't go back and forth between positive and negative, but geometric can because you're multiplying. So if it goes back and forth, that tells you that R has to be negative. So we take 10 over negative 2 is negative 5, negative 50 over 10, negative 5. So yes, it's geometric. Our R equals negative 5. And we're going to take 250 times negative 5 and get this, and then this, and then this. Look at number 4. 8 over 4 is 2. 20 over 8 is 5 halves. Oh, we could stop right there. 60 over 20 is 3. It does not have a common ratio. Whoops, sorry about that. They're different. So no, it's not geometric, and we're done. Number 5, we get, when we do all of that division, we get negative 1/4 each time. You can see it goes back and forth between positive and negative again. And so it is geometric, and our ratio is negative 1/4. So we get 1 over 64, negative 1 over 256, and 1 over 1040. Number 6, again, we get a 2, and then we get a 4, so we can stop and say, no, it is not geometric. Number 7, when we do it, these are all negative. So when we divide, we get positive. So yes, it is geometric, and our ratio is 7. And when we go ahead and multiply each of those by 7, we get these numbers. They go up very big, very quickly when your ratio is big. And number 8, you can see here, the common ratio is 2.5. So yes, it's geometric, and you can go ahead and do that and get those terms. Okay, that's how you tell if it is geometric. And our formula for a geometric sequence is AN equals A1 times R to the n minus 1. Okay, in some ways, I think geometric is easier than arithmetic, so we'll see as we go along. And this is where A1 is the first term, and R is the common ratio. All right, so let's look at some examples. Here we've got example number 9. We have a sequence, and it is asking us to write a rule and then find a 6. All of these are geometric. You don't have to check to see if it is geometric. They are geometric, but you do need to find R in order to use this. So A1 here is 1, and R is 5. So our equation that we're going to come up with, our rule is AN is 1 times 5 to the n minus 1, which of course we can just write as this. We don't have to put that 1 there. You can if you want, doesn't matter. And then it asks us to find A6. So we're just going to, I'll keep the 1. We're just going to put a 6 in for the n. So we get this as 1 times 5 to the 5th power, which is 3125. And that is our answer. All right, let's look at number 10. 130, 65, 32.5, and 16.25. So it's going down, which tells you that your R is going to be a fraction. So our A1 is 130, and our R, you can take any two terms to find it, those two or those two that are next to each other. So if I take 65 over 130, I get a half. So my rule is going to be 130 times 1/2 to the n minus 1. So when it asks you for a rule, that's what it's going to look like. And then to find A6, we're just going to substitute in 6 for n. So that's going to be 130 times 1/2 to the 5th. Whoops, 1/2. I said 5. So you do this first and then multiply it by 130. And if you do that, you should get 4.0625 in this case. All right, let's look at number 11. We've got A1 is 2, and R is -4. So our rule is 2 times -4 to the n minus 1. And A6 is 2 times -4 to the 6 minus 1, or 2 times -4 to the 5th power. Okay, you got to put that in parentheses when it's, especially when it's a negative. And in this case, it's going to be negative 2048. Number 12, we have A1 is 8, R is 3. So our rule is 8 times 3 to the n minus 1. And A6 is 8 times 3 to the 5th. That's 6 minus 1. And you should get that. Number 13, A1 is 135. R is 2/3. So our rule is 135 times 2/3 to the n minus 1. A6 is 135 times 2/3 to the 5th, which is 17.7 repeating. And the last one of these, number 14, A1 is -3200, and R, I'm going to choose to use some terms farther down because it's going to be easier for me with smaller numbers, is -1/4, but it doesn't matter. You can use any two consecutive terms. You're going to get the same thing. -1/4 to the n minus 1. So A6 is this, which equals 3.125. All right, that's if you're given or can figure out A1 and R. What happens? Let's look at number 15. We have A1 is 7 and R is 4. Find A8. Okay, I'm going to put the formula up here so we can remember what it is. So we're going to say A8 is 7 times 4 to the 8 minus 1. Whoa, not 8 minus 7. Which equals 7 times 4 to the 7th, which equals 114,688. Okay, number 16, we've got A5 equals negative 68, and R equals negative 0.5. Now we want to find A1. So we're going to say negative 68 equals A1 times negative 0.5 to the 5 minus 1. This right here is our n. And now we got to solve for this. So what are we going to do? We're going to first do this, negative 0.5 to the 4th power, which equals 0.06, well, not that. It equals, why do I keep putting in negative? 0.0625, and then we'll divide by that so that we can solve for A1, and we should get that. Okay, so that's what you do when you're given an AN and an R, and then that N tells you what that N is to find A1. Look at number 17. We're given an A1 and an AN, so we have an N, but we don't have an R. So we're going to have to find the R. Okay, so we have A1 equals 13, A4 equals 4459, and we're looking for A3. So we're going to have to do 2 steps. We're first going to have to find R, and then we can use this equation up here to find A3. So let's substitute in what we know. AN equals A1 times R to the n minus 1. So let's solve for this. We're going to divide by 13. So we get 343 equals R to the 3rd. Okay, there's a couple things you can do. You can notice if you know that this is 7 to the 3rd. You can say R equals 7. Or if you don't know that, you can take each side to the 1/3 power on your calculator. If you take 343 to the 1/3 power, you're going to get 7. Okay, so you need to find out that R is 7. That's our first step. Now we can find A3. That's what we were looking for. So we can say A1 times R to the 3 minus 1, and that is 637. All right, number 18. We've got A2 equals 6 and A5 equals 0.048. Find A4. All right, so I'm going to kind of rename these and call this A1, which means then if A2 is A1, that means that A5 is A4. And I'm going to do that just to find R. So I'm going to say A4 equals A1 times R to the 4 minus 1. And I'm going to divide by 6. So I get 0.008 equals R to the 3rd. Again, I'm going to take this to the 3rd power because R cubed to the 3rd power just equals R, and this equals 0.2. So that tells me what R is. Now I'm going to go back to my real numbers to find A4. So I'm going to say A4. Oh, I got to find what A1 is then. Okay, we got to do another step in order to use that. So if A2 is 6, oh, I just erased that. If A2 is 6, A1 is 6 divided by 0.2, which is 30, yeah. So A1 is 30. So to find A4, I'm going to say 30 times 0.2 to the 4 minus 1. Do that on my calculator, and I should get 0.24. All right, let's do the application. Jackson bought a brand new car for $3,800, $38,000. If the car depreciates in value by 20% each year, what will the car be worth in 8 years? So we know that A1 is 38,000. That's where we're starting. And how much is it changing each year? It's going down by 20%. So our R is 0.8. That's how much we have left. 1 minus 100% minus 20% is how much we have left. So we want to find A8. So we're going to say, to see how much it's worth in 8 years. And do this on your calculator, and you should get $7,969.18. Okay, that is the end of geometric sequences. Now the next one is going to be geometric series.